Hello everyone, we have this problem with us. We'll solve this using graph theory. Okay, so first of all, what is being said? Okay, so there are a equation. Let me rephrase that. So this is cos of x into x plus 1 equals to 2 to the power x plus 2 to the power minus x by 2. Okay, so this is the equation for which you have to find solution. So first of all, let us divide this equation into two parts. First is y equals to cos of x into x plus 1. This is 1. And the second is y equals to 2 to the power x plus 2 to the power minus x by 2. This is the second part. Okay. Now let us do this one. Y equals to cos x. How does the graph look? So this is, if this is x axis, this is y axis, the graph looks something like this. Okay, something like this. Yeah, we are extending the x-axis this way. Okay, and the similar way it will go like this in the y-axis as well. Now this point is 1 and this point is y by 2. Okay, yeah, so that is the first graph. Now we have to transform this. So this was y equals to cos x, and how this x, how did it change? This x was simply like this. So you can take a sharp graph of this, like y equals to x. If x was changing like this in a straight line like this, then y equals to cos x would have changed like this, right? Like this, not not this, yeah, something like this, yeah. All right. Now instead of this x, we have what? We have y equals to x into x plus 1. Okay. Now what? Y equals to x plus x into x plus 1. Now the instead of this y equals to x graph that we have here, we have this y equals to x plus 1, x into x plus 1. This is simply like this, right? This graph is like this. Yeah. So this is minus 1. You see, this was increasing slowly, but this acceleration is much higher. So our y equals to, so this graph y equals to cos of x into x plus 1. This will also follow similar pattern, but it will accelerate much faster, right? So this is again, this will be 1. This is like this. Okay, something like this you can assume. So yeah, something like this. And at after this minus 1 point also this side, so I am deleting this graph here. Yeah, this also will be something like this, right? So if we extend this, this will also be something like this, right? Yeah. Now what? Now that we have it, in between these 2 points, see, this never actually crosses pi by 2. This value is minus 1 by 4 if you calculate. Okay, so your graph is something like this. Yeah, so this is our graph of y equals to cos of x into x plus 1. This is first graph. And what is the second equation? The second equation was this one, right? Now this was a combination of these two equations, y equals to 2 to the power x and y equals to 2 to the power minus x. So 2 to the power x graph is simply this, right? And what about 2 to the power minus x, right? So this is y equals to 2 to the power minus x, and this is y equals to 2 to the power x. Now if you add both of them up, what will happen? You will have a third graph. This point will be 2, and both it will look something like this. Okay, so this is y equals to 2 to the power x plus 2 to the power minus x, right? Now our equation was y equals to 2 to the power x plus 2 to the power minus x by 2, right? So again this will come down to some point. What point? So first of all we will delete this, right? And yeah, so not this is not important right now, right? So this is the only equation we have. Now it will come down again to some point. What point? Something like this, right? Because we are dividing it. Yeah, so this equation is now y equals to 2 to the power x plus 2 to the power minus x by 2, and this point is 1, right? Because we are dividing it, and this 2 divided by 2 is 1. Now there are two equations again. You remember this was the first equation, this was the first equation. If we draw this again, it will be something like this, right? This will be something like at 0, like this it will accelerate at each point, right? Accelerate at each point, yeah. And at minus 1 again, at minus 1 again it will be something like this, yeah. And in between it will be something like this, yeah. That was our first equation, and this point was 1, right? And for this second equation it was something like this, yeah. So let me draw this here. So it was something like this, yeah. Oh, here you see there is only one point these two graphs can intersect, right? So the number of real solution is 1. So yeah, just a tip here, if you see a problem like this in an exam where the like time is very constant, I would say my advice would be to skip it altogether, yeah. uh, but yeah, if you want to solve this problem with this graph, with the help of graph theory, you can solve it in this way. This is in my opinion it would be much cleaner solution compared to other solutions that you will find in the internet, but that may be just my bias because I really like graph theory, yeah? All right, see you in a new video with a new problem. Bye for now, and thank you for watching this one. Okay, all right.